Right, so I've built probably about 5 or 6 bows now, about 4 of them recurves, and one of the biggest problems I've had is actually trying to get the tiller right on the bows. This one here is the second recurve that I made, and as you can see, it's got some problems. So, first of all, the upper limb compared to the lower limb has got a significantly different bend on it. You can see here I've just used circles basically, and I've made them so they kind of line up with the tightest point of the bend, just to demonstrate the difference in bend. Just to confuse matters, you'll also know that the upper limb seems to withdraw further than the lower limb. So if you're trying to, use a photograph for dynamic tiller, it can kind of confuse matters. So just to be aware of that. So I did some experiments then to find out what's going on here and basically work out how to fix it. Firstly, as you'd expect, if we have the bow held in the centre of the riser and the string held in the centre, both limbs bend equally in the same distance. Here I've moved the pressure point on the riser lower down, and as you can see, it changes things a little. So for reference, if we imagine that the left of the screen is the top limb and the right of the screen is the bottom limb, the first thing that happens is the bow tilts backwards. The second thing that happens is that the lower limb is bent more than the upper limb. So again, just using those circles just to demonstrate the difference in the radius that they're forming as they're bending. So on this one, the pressure point stays the same in the centre of the riser, and the string is held towards the top limb. And we can see a similar thing that happens to the last example. So first of all, the bow tilts backwards again. And secondly, the lower limb is put under more stress, creating more bend in that lower limb than the top limb. And if we put these two things together and basically put pressure lower on the riser and hold the string towards the top of the bow, these problems are exacerbated. So in this case, the bow tilts backwards a lot, and the difference between the stress placed on the upper and the lower limb is significantly different. So what does this look like on a real bow, and how much of an effect does it really have? So this is, I think, the 4th recurve bow that I made, and the blue line shown there is the centre line of the bow. That red arrow is basically pointing to more or less where the pressure point would be on the riser. And if you're shooting split finger, the red arrow on the left would be showing more or less where the grip on the string would be. So immediately you can see the difference from centre line. We've got the riser held below centre and we've got the string held above centre, which is immediately going to put pressure on that lower limb. So the left hand side of the bow square shows the centre line of the bow, and the blue arrow shows the point of pressure that we're applying to the riser. So it looks like it's approximately 3 centimeters below the centre line that we're actually putting pressure onto the riser. So the left hand side of the bow square again is showing the centre line of the bow, and if shooting split finger, we're probably talking about 4 or 5 centimeters above centre that we're applying pressure to the string. So you can't really build a bow with equal limbs, which is exactly what I've done in the first bow that I made, which is a laminated flat bow, straight limbs, and I've positioned it so that what I thought would be the centre of pressure on the bow hand would be in the centre of the riser. But with the string hand position, it changes things a lot. So there's a couple of things that we can do. First of all, we can shorten the lower limb to make it stiffer, and that's exactly what I had to do eventually on the first bow that I built, and I took almost 2 inches off the lower limb until it finally shot in a balanced sort of way without vibration. The second thing we can do, which is what I've been doing more recently, is thickening the laminations on the lower limb, again to increase that stiffness. So assuming we've got a bow that's something like tillered, I then want to have a look at the difference that's made by moving the hand up and down the string. So this could be as a result of either changing the knocking point, it could be string walking, or it could be the difference between split finger or 300 shooting. So this here is demonstrating where I'm drawing the bow with split finger. Now I rotated the image so that I could basically compare how far the limbs were being drawn. Now, because the bow usually tilts, I've rotated the image so it lines up vertically with that maple strip in the center of my bow, which I know is basically running sort of perpendicular to the draw. So if just to draw your attention at the top there, so the bottom limb's lined up and the top limb tip, you can see the gap where it's actually not been drawn as far as the lower limb. Now this one's 300, you can see the gap is narrowed, so moving the hand down the string is basically applying less pressure to the bottom limb, more pressure to the top limb. And this one's at a 5 centimeter crawl, and as you can see, this is balanced, both limbs being drawn back equally. This is what this bow was actually tillered for, which I use for string walking. So the 5 centimeter crawl equates to a roughly 20 meter point on for me. So the other thing that can happen is changing the pressure on the bow hand. So this one here shows pressure being applied through the webbing of the hand. So the bottom tip is lined up with the ruler there, and just to draw your attention to the top tip, you can see the gap that exists there. So when pressure is applied through the heel of the hand, there's a slight difference where you notice the gap increasing at the top tip. So as we've seen before, if you apply pressure lower on the riser, it increases the force on the bottom limb, decreases it on the top limb. So what does all this mean then? So from my own experience shooting that first bow, when a bow has one limb being drawn further back than the other, it shoots horribly. There's a lot of vibration in the bow, it's noisy, it feels unstable, and it's hard to be accurate. And we can see this in that if one of the limbs is drawn back significantly further than the other, it's going to return to its resting place at a different time to one that isn't being drawn back as far. Also, it's going to be applying more pressure and more force to the knock of the arrow, which again potentially could affect the flight of the arrow. So hopefully this has been of some use. It's just a little experiment of myself to try and work out in a sort of clear and visual way what is actually going on with bow tiller to help me understand how to actually make a better balanced bow. So thanks for your time, and bye.